Volcanoes are scary. Most of them are at least a little dangerous, but some are just so big that it's hard to even wrap your mind around their sheer destructive potential. And in this episode, we look at one of the worst ones, the supervolcano apocalypse. Could we actually stop it if one started today? There are more volcanoes on Earth than you probably think. There are about 40,000 of them, and almost 1,300 have had explosive eruptions within the past 10,000 years. A volcanic eruption is measured by its volcanic explosivity index, or VEI, which considers both the height of the eruption column and the volume of material ejected during an eruption. The higher the number, the bigger the explosion. At the top of the scale, a VEI 8, are the supervolcanoes. These catastrophic eruptions eject more than 1,000 cubic kilometers of debris and produce ash layers more than 6.5 meters deep. There have been 7 known super-eruptions in the past 2 million years, but thankfully none have occurred in the past 12,000 years. So what exactly causes a supervolcanic eruption? Well, all volcanoes start out as magma chambers that form beneath the Earth's surface when rock in the mantle melts. When the magma finds cracks in the crust through which it can push up, it forms a volcano. But not all magma chambers lead to volcanoes. If the magma chamber is deep enough and under enough pressure, it can stay there without erupting, and some stay there for millions of years. Eventually, though, the pressure from the magma overcomes the strength of the rocks above it. The roof of the magma chamber collapses and a massive eruption occurs. This is what happened with the most recent super-eruption at La Garita caldera in Colorado, which had a VEI of 7 and took place 27,000 years ago. The trouble is that we don't always know when the pressure will become too much for the roof of the magma chamber to support. But scientists do have a theory on how to tell if one is likely to blow soon. See, although there haven't been any super-eruptions in the past 12,000 years, there have been a few near misses. In the past couple of centuries, we've seen magma chambers that were once thought to be dormant begin to stir. For example, at Mount Vesuvius in Italy, home to the infamous Pompeii, a magma chamber 30 kilometers below the surface began to fill after having been quiet for 1,000 years. Similarly, the magma chamber under Mount Ibu in Indonesia, which had been quiet for 300 years, suddenly rumbled back to life. And these aren't isolated examples. From 1985 to 2005, scientists identified 26 volcanoes worldwide that showed signs of renewed activity in their magma chambers. But what does this mean for the risk of a super-eruption today? It turns out that the best way to find out if there's magma building up below a volcano is to listen very carefully to the volcano itself. See, magma is always moving. It's slowly seeping into the magma chamber, and the roof of the chamber is always shifting and settling. All of this movement causes stress to build up in the rocks surrounding the magma chamber. And when the stress is released, it produces seismic waves that can travel along the magma chamber and be picked up by local seismometers. Scientists can use these seismic signals to map out what's happening below a volcano. And while they won't be able to tell exactly when an eruption might happen, they can get a sense of the likelihood that one is imminent. For example, between 2015 and 2017, seismic sensors in the Italian island of Stromboli recorded a series of low-frequency earthquakes that suggested magma was accumulating in the magma chamber. Now, it's not like Stromboli hadn't exhibited these signals before, but this time they were stronger than ever. The researchers concluded that the magma chamber had filled up to 80% of its capacity and predicted that an eruption was imminent. Sure enough, in early 2019, Stromboli erupted. It wasn't a super-eruption, but it did catch scientists by surprise. They'd never seen those low-frequency earthquakes be quite so intense. So this technique may help pinpoint the next supervolcano to erupt, but it won't necessarily give us much warning. At the end of the day, if we see these seismic signals, and we know there's a supervolcano that could erupt, what are we actually going to do about it? Unfortunately, our options are pretty limited. One strategy we can employ is evacuating the area around the volcano. Of course, the problem with this approach is that the people who live nearby might not want to leave their homes. After all, Even though supervolcanic eruptions are rare, smaller eruptions are common, and evacuating every time would be a huge disruption. Even if evacuations were possible, how far away from the volcano would be safe? The area covered by ash from the last super eruption in the Yellowstone supervolcano was over 100,000 square kilometers and extended over parts of 7 American states. Super eruptions are just so large that even getting far away from the epicenter doesn't guarantee safety. In fact, one of the worst things about supervolcanic eruptions is that they tend to trigger other volcanoes. That's because the initial explosion blasts the gases and ash high into the atmosphere. As the ash starts falling back down to the ground, it spreads across the region and covers everything in a layer of fine particles. The ash makes its way into the cracks of other volcanoes, pushing their magma up toward the surface and sometimes causing them to erupt as well. So, if an eruption is imminent at one supervolcano, evacuations might not even help. Which brings us to another option: stopping the eruption at its source. Some small volcanoes are capped off by solid plugs of rock that are pushed up from the magma below, and when the magma chamber beneath the plug gets too full, the plug can melt, allowing the magma to escape. In 1980, geologists noticed that the lava dome at the summit of Mount Unzen in Japan looked suspiciously like it might melt soon. They recommended evacuating the area just in case. And sure enough, a few days later, the plug melted, and thousands of tons of pyroclastic flow poured down the mountainside. Luckily, there weren't many people nearby, and no one was killed. But this event proved that it is possible to stop an eruption by removing the cap of a volcano. This idea has been proposed for larger volcanoes, including Mount Vesuvius, but it's obviously not feasible for supervolcanoes, which have enormous magma chambers spanning tens of kilometers, as well as being filled with liquid magma rather than just a solid plug. But there is one place that has tried to stop a volcano in a similar way: North Island, New Zealand. North Island is a geothermal wonderland. It has more than 10 active volcanic centers. In 1940, Manunui, also known as the Red Crater, began to show signs that it was about to erupt. The locals knew that if it erupted violently, they'd only have minutes to evacuate, so they decided to try something crazy, draining the volcano. Geologists dug a tunnel 1 kilometer into the side of the mountain. Then they drilled a borehole from the tunnel into the magma chamber. The plan was to pump water into the borehole and steam would escape and bring the pressure in the magma chamber down. Once the pressure was low enough, the magma wouldn't be able to bubble up and fuel the eruption. To their surprise, it worked. But that success didn't last long. The crater erupted 3 times over the next 13 years. But now that scientists knew that you could drain the magma chamber, they could prepare better. In 1975, they successfully lowered the magma chamber pressure and prevented an eruption. And the same thing was done again in 1996. But the pressure dropped too quickly, and part of the crater collapsed. Although no one was hurt, this failure prompted officials to abandon the risky strategy. But what if we could somehow prevent the magma from getting into the chamber in the first place? A paper published in 2023 proposed just such a plan for supervolcanoes, except instead of drilling a hole to the magma chamber, this method would involve drilling miles into the hot rock of the mantle below the magma chamber. The idea is to build a barrier to keep the magma from rising into the chamber in the first place. Unfortunately, this would require a lot of manpower and money, and it would need to start long before any signs of an imminent eruption. It's unlikely that we'll ever be able to fully stop a super-eruption once the magma starts filling the chamber. If we want to prevent the next global catastrophe, we should probably focus on spotting them coming as early as possible and getting out of the danger zone. Thanks for watching this episode of SciShow, and thanks especially to our supporters who helped us make this happen. You guys are really helping us reach more people with our educational videos.